Good evening, students online. Priyasha, Lakshmi, Hitesh, Meera, and Rajeshwari.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening, children. Yeah, and good evening, all of you here. Fine. So today we are going to start a new chapter, circles. So since it's a revision program, in this class we will not be seeing the proofs to the theorems, but I'll only tell you about the different theorems which you will come across in this chapter and which will be needed to solve numerical questions in this chapter. Am I audible? Am I clear?
Yes, ma'am.
Oh, I haven't
Yes,
shared my
ma'am.
presentation. Oh, no, 1 second. I haven't shared my presentation. Children, as soon as I start the meeting, I share the presentation. If it is not done, let me know in the beginning itself. Don't wait to tell me. See, today I forgot to share. Yeah. My presentation is right now empty. Is it visible?
Yes, ma'am.
Yes, ma'am.
Yeah. Yeah, fine. Okay, so the first and the most important theorem in this chapter is about the relationship between the tangent and the radius drawn through the point of contact. So circle, okay, circle, tangent. Okay, so let's say that AB is a tangent to the circle at P. AB is a tangent to the circle at P. That is, you know that a tangent is a line which meets the circle at exactly one point. See, on the circumference of the circle, there are so many points. On the circle, there are so many points, and a line also extends indefinitely on both the sides. So on the line also, you have so many points, but there is only one point common between the circle and the line. The circle has many points on it. The line AB also has many points on it, but there is only one point P, which is common to the circle and the line. There is only one point P, which is on the circle as well as on the line AB, which means P is the point common to the circle and the line AB. P is the only point common to the circle and the line AB. So we say AB is a tangent to the circle at P because it touches the circle at exactly one point. So that is what a tangent is. A tangent is a line that touches a circle at exactly one point. A tangent is a line that touches a circle at exactly one point. Yeah. So yeah, that's what is a tangent. Correct? All get that? Okay. Okay, so P is the only point common to the circle and the line AB. So AB is said to be a tangent to the circle at P. Now let's draw the radius through the point. Now P is called the point of contact. P is called the point of contact. Let's draw. Yeah. Let's draw the radius through the point of contact. Let's draw the radius through the point of contact. Now OP is the radius. OP is the radius drawn through the point of contact P. OP is the radius drawn through the point of contact P. Now the relationship between this radius and the tangent is that they are perpendicular to each other. They are perpendicular to each other. Okay, so the tangent The P is the point of contact. Children are still coming, so I'm distracted. Yeah, comes along. Oh God, tell your father the class finishes at 9:30 today. He's gone. Okay, so the relationship between. Okay, you can call him. You can call him. We may forget. Call him and then you sit down in the class. What's the number? 944-266-266-743. Yeah, so OP and AB are perpendicular to each other. OP is perpendicular to AB, which means angle OPA is 90 degrees or angle OPB is 90 degrees. This is one. Then, so this is one result, that the radius and the tangent at the point of contact are perpendicular to each other. This is one result. Next. Now, when you take a point inside the circle, you cannot draw any tangent to the circle. Given a point inside the circle, you cannot draw any tangent to the circle because the point is inside the circle. When you try to draw a line, it cannot be a tangent to the circle. It's a secant. What do you call this line? This line is called a secant to the circle because it intersects a circle at two distinct points. Now, this line is a secant to the circle. It's not a tangent. It's a secant. A secant is a line, not a line segment. What's the difference between a chord and a secant? What is the difference between a chord and a secant? A chord is a line segment. A chord is a line segment which has its endpoints on the circle. A and B are the endpoints of the chord on the circle. Now this line AB is a secant. Okay, I can mark AB here also. See AB here. When you talk about the line segment AB, it's a chord. When you talk about the line AB, it is a secant. When you talk about this segment is a part of the circle. Segment is a part of the circle. Sorry, a segment is a part of a line. Line segment meaning a part of the line. So when you talk about this line segment AB, it is a chord to the circle because we're talking about the line segment AB, which is a chord to the circle. It has its endpoints on the circle at A and B. But when you talk about the line AB, this line AB, that's how we name. No, how do you name lines? You draw a line and then you mark 2 points on it and you say line PQ. This is how we say line PQ. Line PQ. So when you talk about the line line PQ is a secant to the circle. Okay, it's a secant to the circle because it meets a circle at two distinct points, A and B, correct? So that's about tangent and secant, and you cannot draw any tangent to a circle given a point inside the circle. When you take a point inside the circle, you cannot draw any tangent to the circle. Now let's take a point on this. There are three different positions you can take with respect to the circle. There are three different positions which you can take with respect to the circle. You can take a point inside the circle, you can take a point on the circle or outside the circle. You can take a point inside the circle, you can take a point on the circle, or you can take a point outside the circle. So these are the three different positions. Now, when you take a point inside the circle, you cannot draw any tangent to the circle. So no tangent can be drawn. No tangent can be drawn through a point lying inside the circle. No tangent can be drawn passing through a point which lies inside the circle. Now on the circle, there's one and only one tangent. Okay, there's one and only one tangent that can be drawn passing through a point on the circle. When you have a point on the circle, you can draw only one line, which can be the tangent to the circle. All right, if you try to draw another one, it will become a secant. If you try to draw, no, that it may pass through that point, but it will be a secant. It will not be a tangent. So when you take a point on the circle, there's one and only one tangent that can be drawn passing through a point lying on the circle. Now, when you talk about this point which lies outside the circle, exactly two tangents. Exactly two tangents can be drawn passing through a point lying outside the circle. See, like this. So you can draw one tangent like this. This is a tangent segment. See, we call them the tangent segments. Like you say, line segment, which is a portion of a line. Line segment is a part of a line. Tangent segment is a part of a tangent because a tangent is a line. A tangent is a line. So when we say tangent segment, it's a segment meaning a part of something. Segment is a part of something. So when we say tangent segment, it's a part of the tangent, which is a line. Tangent is a line. A part of the tangent, that line, is a tangent segment. And what you see here are tangent segments. They're not tangent because tangents are not line segments. So they extend, they go on like this. See, it goes on like this. See, it goes like this. They're lines, no? So these are the tangents. These are the tangents. This is the external point. This is the external point. And you can see that this is one tangent. And this is the other tangent, which can be drawn passing through this point given outside the circle. They are lines. They are not line segments. But when we draw, we only show the tangent segments. We don't show the tangent fully like, like what you see here. Okay, so we only see these segments. So normally we see a figure like this. We see a figure like this. Circle, some point lying outside the circle, and we'll only see these portions. So then you'll wonder, now these are line segments, but we understood that tangents are lines. They're lines only. These are tangent segments. From here to here is a tangent segment. From here to here is the other tangent segment. So what is the tangent segment? What is the length of the tangent segment? It's the length. What are the endpoints of a tangent segment? One endpoint is the external point. The other endpoint is the point of contact. Now this is, say, the external point P, A and B. Okay, A and B are the points of contact. One tangent meets a circle at A. The other tangent meets a circle at B. So A and B are the points of contact. A and B are the points of contact. PA is a tangent segment. PB is another tangent segment. You can produce PA and PB on both the sides. They are the tangents. So PA and PB are the tangent segments. And that is what we find. When they ask you to find the length of the tangent, tangent is a line, you cannot find its length. But what you're finding is the length of the tangent segment. What you find is the length of the tangent segment. All right, so PA and PB from the external point to the point of contact. From the external point to the point of contact is the tangent segment. All right. So what have we learned? That the tangents drawn from an external point of the circle are equal. The tangents drawn from an external point of the circle are equal. All right. We know how to prove this by congruency. Congruency, we know how to prove this. All right, maybe we'll see the proofs in the next class because with great effort I've prepared the presentation, and now if I'm proving all this in the class, then I can't use my presentation. So anyways, we'll see it in the next class, maybe towards the end of the session. Very simple proofs based on congruent triangles. So now what you need to understand is the tangents from an external point to the circle are equal in length. PA is equal to PB. PA is equal to PB. Fine. Now let me connect. This is the center of the circle. This is the center of the circle. Let me join OA and OB. Let me join OA and OB. And so OA and OB, radii of the circle. Let me also join the center of the circle to the external point P. Let me join the center of the circle to the external point P. What is the first thing we understood? PA is equal to PB. Tangents drawn from an external point of the circle are equal in length. That can be proved. We'll see it later. Now remember this result. Then what did we do? We joined the points of contact to the center of the circle. We joined the points of contact to the center of the circle. And we also joined the center to the external point. We also joined the center to the external point. So now we have a figure like this. Now let's understand these angles. What are these angles called? This angle and this angle, what are they called? This angle and this angle, what are they called? Okay, now first thing is angle 1 is equal to angle 2. Angle 1 is equal to angle 2. Also, angle 3 is equal to angle 4. Results are, and so what are the results? PA is equal to PB is one result. Angle 1 is equal to angle 2. Angle 3 is equal to angle 4. These are the results you need to remember. PA is equal to PB. Angle 1 is equal to angle 2. And angle 3 is equal to angle 4. Now, how do we explain or how do we describe angle 1 and angle 2? How do we describe angle 1 and angle 2? Angle 1 is the angle subtended by the tangent segment PA at the center. What is angle 1? Angle 1 is the angle subtended by the, you can just say tangent also. You don't have to say tangent segment. Tangent means here tangent segment only. Okay, so angle 1 is the angle subtended by the tangent PA at the center O. At the center O. Now you'll worry, you'll wonder like how. See, this is the tangent. We'll understand how we identify the angle subtended by a line segment. We'll understand how to identify the angle subtended by a line segment. What is PA? It's a line segment. It's a tangent. It's a line segment. Now this line segment is subtending or is making an angle at the center. This line segment is making an angle at the center. How do you make out that angle? So see here, look at the ends of the tangent, P and A. Now, meaning what angle are we looking at? The angle made at the center, right? Join the endpoints to the center. Join the endpoints to the center. See here. See, okay, let me draw it again. This is a center O. This is a center O. This is a tangent segment PA. Correct? PA. Now I'm saying if we want to identify the angle subtended by this tangent segment at the center. At the center. For that, join the endpoints. A is one endpoint. Join it to the center. P is the other endpoint. Join it to the center. This is the angle. This is the angle subtended by the tangent segment PA at the center. Simply join the ends of the tangent to the center. Which is the angle formed? This is the angle AOP or POA. This is the angle subtended by the tangent segment PA at the center O. Now, in the same way, circle center O, the other tangent PB. PB is other tangent. Now, the angle made by this tangent PB at the center, the angle made or subtended by the tangent PB at the center. How do you identify that? Join the ends B to the center O and then P to the center O. Now you can see an angle formed here. That's what is this one, angle 2. So angle 1 is the angle subtended by the tangent segment PA at the center. Angle 2 is the angle subtended by tangent segment PB at the center. Correct? Children, if you want to make a note of something, you can do it. If you want to draw this figure and write down this angle 1 is the angle subtended by All right. Okay. Next, what about 3 and 4? Now, 3 and 4 is the inclination. Is an inclination. Now, angle 3 is the inclination made by the tangent PA with respect to the line segment OP. I'll clear the slide, children. I'll just take away all this. Now we're trying to understand angle 3 and angle 4. What are angle 3 and angle 4? Okay, so angle 3 is the inclination, of the tangent PA with the line segment OP. What is OP? OP is a line segment joining the center and the external point. What is OP? OP is the line segment joining the center and the external point. Now, this PA, see, just imagine like it's a mouth which is opening. This is the line segment OP. Okay, and this is PA. This is PA. So this is the angle, right? This is the angle between OP and AP, right? That is what is inclination. It's like as if this tangent is inclined at an angle of this one with OP. The tangent PA. Now, supposing I say 30 degrees. Okay. The tangent PA is inclined at an angle of 30 degrees with OP. What is OP? It's a line, or it's a line segment joining the center and the external point. See, whenever we mark an angle, whenever we measure an angle, don't we take a baseline? To measure an angle? Using a protractor, you first draw the baseline and then only measure the angle. So that's what it is here. So that OP is like the baseline. And PA is the inclination. PA is the tangent. And this angle APO is the inclination. This is the inclination. So we say that the tangent PA is inclined at an angle of 30 degrees with OP. Yeah, children. Now tell me, what do you say about angle 4? What do you say about angle 4? Angle 4 is the inclination of the tangent PB with the line segment OP. So OP is the baseline, correct. OP is the baseline for both the angles. OP is the baseline for both the angles. So the tangents are inclined. So see, I'll just give some number. I'll just give some number. Supposing I say this is 30 degrees and this is also 30 degrees. So we say that a tangent AP is inclined at an angle of 30 degrees with OP. Similarly, tangent BP or PB is inclined at an angle of 30 degrees with OP. Is that clear? So when they talk about the inclination of the tangent with the line segment joining the center and the external point. What is OP? It's a line segment joining the center and the external point. That acts as the baseline here. Okay, OP. Center, external point. That line segment is OP. So the tangent PA is inclined at an angle of 30 degrees with the line segment OP. What is OP? It's a line segment joining the center and the external point. So the result is equal tangents are equally inclined. Equal tangents are equally inclined to the line segment joining the center and the external point. So now let me write all the results. So these are the equal tangents from the external point P. PA and PB are the tangents. Listen to me, you can write down later. We'll recall. So PA and PB are the tangents from the same point P, so they're equal. So PA is equal to PB. This is the center O. We join OB and OA. Let me make a better figure. All right, then we also join the center to the external point. We also join the center to the external point P. Now, angle 1 is equal to angle 2. Angle 3 is equal to angle 4. And PA is equal to PB. These are the results. PA is equal to PB, you understand the reason. Equal tangents from the same external point. Then the next thing is angle 1 is equal to angle 2. So for this, we say equal tangents. Angle 1 is equal to angle 2. Equal tangents subtend equal angles at the center. Equal angles at the center. Understand? Equal tangents. Now P and PB are equal tangents. So they will make equal angles at the center. So angle 1 is equal to angle 2. Okay. Then angle 3 is equal to angle 4. This is the result. What's the reason? What do we say? We say equal tangents because PA and PB are equal tangents. Equal tangents are equally inclined. Equal tangents are equally inclined to the line segment joining the center and the external point. Write on this fast, external point. That's all. With this, we'll get started with the exercise. None? Students online? Meera, Rajeshwari, Priyasha, Lakshmi and Hitesh finished writing?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yeah. All right. So apart from this, what we have to remember is the relationship between the radius and the tangent. Radius is perpendicular to the tangent. Simply remember like this in short. You know what it means. Okay. So if this is the tangent, this is the point of contact. Radius through the point of contact, perpendicular. This is 90 degrees. So this is one thing you'll have to remember. And then equal tangents P and PB. Angle 1 is equal to 2, 3 is equal to 4. These positions you remember. They're equal. All right. Okay. Next, we'll have to go down to 9th standard also. What is the measure of this angle? What is the measure of angle? What's the measure of angle X? What's the measure of X? X is equal to 90 degrees because, yeah, angle in a
90.
semicircle. Correct. Angle in a semicircle is a right angle. 9th standard. Angle in a semicircle. Now, how do you know it's the angle in a semicircle? Because AB is the diameter. And how do we know that AB is the diameter? Because it passes through the center O. Whenever you see the letter O, it represents the center of the circle. O is always the center of the circle. Okay, it goes without saying. If it is some other letter, then it should be specified. It should be mentioned that it's a center. If it is O, O is always the center of the circle. So AB is the diameter because it passes through the center. And then you can see the diameter subtends. The diameter subtends an angle on the circumference. See here, from this C is a, okay, fine. Let me explain that. See here, AB is the diameter. AB is the diameter because it passes through O. C is the point on the circumference. Now join the ends of the diameter to the point C. Join the ends of the diameter to the point C on the circumference. So join A to C, correct? And B to C. This is the angle which is 90 degrees. Join the ends of the diameter to that point on the circumference. That's the angle which is 90 degrees. All right. Now you can see here in this figure from A to C and from B to C. This is the angle. X is equal to 90 degrees. Angle in a semicircle is a right angle. Correct? Make a note of that. Okay, you all understand what it is. Now, what is this is angle AOB. This is angle AOB. Okay, can anybody tell me the relationship between angle AOB and angle AOC? Sorry. The relationship between angle AOB. Is there any relationship between angle AOB and angle ACB? Yes, students? One second. Yeah. Is there any relationship between angle AOB and angle ACB? Yes, online students?
Angle in the same segment.
Angle in the same segment. Angles in the same segment of a circle are equal. Rajeshwari, right?
Yes, ma'am.
Okay. So if angle AOB is say 50 degrees, what will be the measure of ACB?
50 degrees, ma'am.
50 degrees. Okay. Any other opinion? Recall from standard 9. No, don't write this. Unless I tell you write, don't write. We have not still concluded. We're still discussing. We don't know what's right. So this is what Rajeshwari recalls from standard 9. Good. Yeah, others? Opposite? No. Okay, so angles in the same segment of a circle. Nice that you could recall that, but that is different. We'll see that. Now this is the angle subtended by an arc at the center. The angle subtended by an arc at the center is double the angle subtended by the same arc at any point on the remaining part of the circle. So now look at the arc. Let's name the different parts of this figure. The arc is AB. The arc is AB. Yes or no? Now arc AB subtends the angle AOB at the center. Correct? Correct? And the same arc AB subtends angle ACB at the point C on the circumference. Correct? Now where is the arc? This is the arc. This is the arc. This is the arc. That's, see here. This is the circle. This is the circle. And this is the arc AB. Where is the point C? It's on the remaining part of the circle. C is on the remaining part of the circle. C is not on arc AB. The point C is not on the arc AB. It's on the remaining part of the circle. So arc AB subtends angle AOB at the center. The same arc AB subtends angle ACB at the point C on the remaining part of the circle. And the relationship between these two is that the angle at the center, angle AOB, is double the angle on the circumference, is twice ACB. The angle at the center is more. The angle at the center is double the angle on the circumference. So the arc is AB, center of the circle O. C is a point on the circumference, not on the arc AB. C is a point on the circumference of the circle, not on the arc AB, on the remaining part of the circle. Now the theorem goes like this. The angle subtended by an arc at the center is double the angle subtended by the same arc at any point on the remaining part of the circle. So the relationship is angle AOB is equal to twice angle ACB, 9th standard. Able to recall this? So if this is 50 degrees, what does ACB tell me? How much is ACB? Online students?
25 degrees.
100.
Angle at the center is double. Rajeshwari was right, 25. On the circumference, it will be, now substitute here, this is the relation. So AOB is 50. 50 is equal to twice angle ACB. So ACB is equal to 50 by 2, 25. 50 by 2, 25 degrees. Yes or no? The angle at the center is double. Which is more? Center angle is more. On the circumference, it is less. So it should be 25, not 100. All of us understand that? All of us understand that?
Yes, ma'am.
Yes, miss.
Sure. Okay, so this is one other thing which you have to recall and remember from 9th standard. All right, angle in a semicircle is a right angle. Then this one. So write down this. Angle, the angle subtended by an arc at the center is double the angle, is double the angle subtended by the same arc at, write down, at any point on the remaining part of the circle. Remaining part of the circle. So in this figure, angle AOB is equal to twice angle ACB. So if what's the sound from then? Somebody's behind them. Yeah. So if angle ACB is 60, if ACB is 60, how much is AOB? 120, because center is double. If ACB is 60, then center will be 120. If the center is 100, then that will be 50. On the circumference will be 50. Okay. Now what is this? The next one. What are the angles? Angle in the same segment of a circle are equal. That is this one. This is a chord, right? AB is a chord. So this is the major segment. Can be the minor segment also. Now in this case, it's a major segment. Now see here, angle ACB and angle ADB. These angles, they are the angles in the same segment of a circle. They are equal. Angle, now C and D are 2 points on the circumference of the circle in the major segment. Okay. Why you've all studied this in 9th standard, right? Yeah. Okay, so here angle ACB is equal to angle ADB. This is angles in the same segment of a circle are equal because both the angles are in the major segment. C and D are the points on the circumference of the major segment. Angle ACB, ADB, they're equal. So we say angles in the same segment of a circle are equal. All right. Okay. Then, so this is angles in the same segment. Write down the same segment of a circle are equal. Angles in the same segment of a circle are equal. Angles in the same segment of a circle are equal. Hitesh, are you writing everything?
Yes, ma'am.
Yeah, Priyasha, you were not in the meeting for some time. What happened? Priyasha, can you hear me? Okay, angles in the same segment of a circle are equal. Fine, children. Now, give a special name to this triangle. Give a special name. Okay, don't mind, okay? Give a special name to the triangle OPQ. Give a special name to the triangle OPQ. It's an isosceles triangle. Why, Sneha? Because OP is equal to OQ. So OP is equal to OQ. Why? Because the radius of the circle. So that means it's always isosceles. OPQ is always an isosceles. OPQ meaning this triangle is always isosceles. So these two angles will be equal. So supposing this angle is 70, what will be the measure of this angle? Fast. Huh? 55 degrees. What did you say? I couldn't hear you. 55 degrees. If the measure of this angle is 70, 180 minus 70 is 110. That will be shared equally by these two angles. Because these two sides are equal, isosceles triangle property. In a triangle, when two sides are equal, the angles opposite to them are also equal. If these two sides are equal, these two angles are equal. Yes or no? So now if this angle is 70 degrees, the remaining sum is 180 minus 70, 110. Which will be shared equally between these two angles. So 110 by 2, 55 degrees. Okay, so this also will be, this idea will be used somewhere. So you should, when you look at a figure, all these ideas must come gushing into your mind. When you see a figure, you know, all these ideas, is radius perpendicular to the tangent? Are the tangents equal? Or the angle 1 is equal to 2, 3 is equal to 4. You understand what I'm saying? Angle in a semicircle is a right angle. Angle at the center, double the angle on the circumference. Angles in the same segment of a circle are equal. Everything should come to your mind. Then it's very easy. Then this triangle is isosceles. Correct? This triangle is isosceles. Remember that. Yeah, please make a note of this. No, it'll be like what's there to make a note. I'm just for the order. In the 7th one, what we're trying to understand is OPQ is isosceles. That's what it is. OPQ is isosceles. So that means these base angles are equal. Angle 1 is equal to angle 2. Angle 1 is equal to angle 2. That's what we're trying to understand or recall. Done, children, online?
Yes, ma'am.
Yes,
Oh,
ma'am.
all right. Yeah.
Yes, ma'am.
All right. Good. All right. Now we are good to go. Now see this from the figure. Just a minute. Yesterday. Yeah, so I'll be sharing the pictures with you. We're just going to discuss, as I've told you earlier. Okay, so now don't write anything. Just listen. Maybe you can use your notebook for calculation. Don't try to take down the question. You can do it later. Now, from the figure, find x. That's the first question. From the figure, find x. So don't read the rest of the question. Do not read the rest of the question. From the figure, find x. Yeah, who can tell me? See, online students, I don't have to ask you. You just feel as if you're in the physical class. Keep answering. Yeah. Just tell me, I don't want any explanation. What is the value of x? 150. 150. X is equal to 150 because OAPB is a cyclic quadrilateral. We have proved this. We have proved that OAP. See, we have proved, meaning you must have seen this in the chapter circles in the exercise. OAPB, remember that. See, now what you're supposed to do is you should write question number 1. If any information is new to you, you make a note of that. So now I said OAPB is a cyclic quadrilateral. If that's new to you, make a note of it. Now we're not going to work the you're not going to write the question nor going to work it. You're just going to answer my questions. All right. So when I'm explaining, if you feel some part of the information is new to you, make a note of it. You can ask me to repeat if you don't understand. Yeah. Now, because OAPB is a cyclic quadrilateral, Now let's understand how quickly. Now, is this 90 degrees? Radius and tangent. Radius, OA is the radius. This is the tangent. At A, they are 90 degrees. Yes or no? This also is 90. Yes or no? So what is a
Yes,
cyclic
ma'am.
quadrilateral? Yeah. If in a quadrilateral, if one pair of opposite angles is supplementary, it's a cyclic quadrilateral. In a quadrilateral, if any one pair of opposite angles is supplementary, if one pair of opposite angles add up to 180 degrees, it's a cyclic quadrilateral. Now, if one pair adds up to 180, the other pair also will add up to 180 because the total sum is 360, right? It's a quadrilateral. So the total sum is 360. If one pair adds up to 180, the other pair will also add up to 180. So now why is this a cyclic quadrilateral OAPB? Because opposite angles A plus B is equal to 180. Understood? A plus B, or A and B are opposite angles. See, these are opposite angles. These are opposite angles. This is the quadrilateral. See, OAPB, this is the quadrilateral. This is the quadrilateral. These are the opposite angles. Okay, one pair of opposite angles are supplementary. Angle A is 90, B is 90. Why? Because radius perpendicular to tangent. We know this by the theorem. So 90 plus 90, 180. So OAPB is a cyclic quadrilateral. This is the proof. This is the proof. How do you prove that OAPB is a cyclic quadrilateral? This is what you should write. What should you write? You must write that this angle, you can mark it 1. Angle 1 is equal to 90 degrees. Why? The radius OA is perpendicular to the tangent AB by the theorem. Then angle 2 is 90 degrees. Why? Because the radius OB is perpendicular to the tangent PB by the theorem. Now opposite angles 1 plus 2 is equal to 90 plus 90, 180. supplementary. So OAPB is a cyclic quadrilateral. If this one adds up to 180, 360 minus 180 is 180. So this one also will add up to 180. So that's how you do it. So 1 mark, you don't have to work anything. No, straight away. This is 30, then this will be 150. If this is 100, this will be 80. Opposite angle is supplementary. Okay, so find X. X will be 150 degrees. Then also if OP is joined, OP is connected, you know, when you join OP, okay, find BOP, this one, and angle BPO, this one. Tell me quickly, how much is this angle? 75 by the theorem, correct? Because these two angles are equal. We understand angle 1 is equal to angle 2. These two angles are equal. This angle and this angle are equal. This angle and this angle are equal. The full thing is 150. So it will be 75 here and 75 here. What about this angle and this angle and this angle? They are also equal. They are also equal.
15.
Correct. So, but the whole thing is 30. So this will be 15 here and 15 here. The reason for 75 is equal tangents subtend equal angles at the center. And for 15 is equal tangents are equally inclined to the line segment joining the center and the external point. So once again, tell me, how much is this angle? BOP, how much is this? 75 degrees. And how much is this angle? BPO? How much is this?
15.
15 degrees. Yeah, I'm sending this picture now itself because last time I delayed a lot for, you know, like sending quadrilateral. So I'm sending it right away. All of you will be receiving it now. Yeah, it's the same thing. The explanation is just what we understood now. So I'll not show you the slide for a long time. You can see here, equal tangents, subtend equal angles at the center. Equal tangents are equally inclined to the line segment joining the center and the external point. Okay, same explanation. Yeah, this also. This is a result which you have proved in NCERT. This is a result which you have proved in NCERT. If a quadrilateral circumscribes a circle, the sum of the opposite sides are equal. You've proved this in NCERT. Children, in NCERT, you've proved this result. If a quadrilateral circumscribes a circle, then the sum of its opposite sides are equal. Now name the opposite sides of this quadrilateral. Name the opposite sides of this quadrilateral. AB and CD, then BC and AD. AB plus CD is equal to BC plus AD. This is the result. This is the result. The sum of the opposite side. These are the opposite sides. So see here, AB, look at the screen. AB and CD are opposite sides. The sum, look at the screen, look at the board. So the sum of the opposite sides. BC and AD are the opposite sides. The sum of the opposite sides are equal. When a quadrilateral circumscribes a circle, circumscribes meaning touches the circle like this. It's outside. The quadrilateral is outside the circle. When a quadrilateral circumscribes a circle, the sum of the opposite sides are equal. AB plus CD is equal to BC plus AD. Got it? That's the result. So this is how you find. So please go through the answer. Don't write now. We have to go to the next one. Just substitute, write the result. Substitute the sides given and find the unknown AD. The length of the side AD is 5 centimeters. All right. Yeah, this one also. We have proved this result in NCERT. Here also, if a quadrilateral circumscribes a circle, the sum of the opposite angles, the angle. Okay, let me first explain what the figure is. Now see here. Can you see the quadrilateral ABCD? circumscribing the circle? The circle is inscribed in the quadrilateral. The circle is inscribed in the quadrilateral. The quadrilateral circumscribes the circle. It's like we say A is B's father, B is A's son. A is B's father, B is A's son. So like that. In the same way, the circle is inscribed in the quadrilateral. The quadrilateral circumscribes the circle. So you can use both the terms circumscribes and inscribed. Inscribed, both you can use, depends from which aspect you're saying. So this is the figure. So you can see that you can also say that the sides of the quadrilateral are tangential to the circle. The sides of the quadrilateral are tangential to the circle because every side of the quadrilateral act as tangents to the circle. See AB. The circle is outside. Huh? The figure is incorrect, but I'm talking about something. No, the figure is incorrect, meaning, okay, please take the figure like this. I just noticed that. The figure is something like this, children. I'll just change the figure and send the slide later. The figure is something like this. Meaning, I'm talking about a figure like this. All right. So now you can see that A, B, C, D. AB is a tangent. The side AB is a tangent to the circle. The side BC is a tangent to the circle. The side CD is a tangent to the circle. The side AD is a tangent to the circle. Yes or no? The four sides of the quad. Don't see the figure here, children. I've taken a wrong figure. This figure is incorrect. I'm talking about this figure. All right. So you can see that in quadrilateral ABCD, AB, BC, CD, and AD are tangents to the circle. Yes or no? So we say that the sides of the quadrilateral are tangential to the circle. All right. Now, now this is the center of the circle O. Now, what is when I join AO and DO? What is it? It's the angle subtended by the side AD at the center. Now, if I join AO and BO, it is the angle subtended by the side AB at the center. Now, what is this? So now tell me. Now, what is this angle? Priyasha, are you there? No, Priyasha is not there. Hitesh? 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 Meera? Why? Nobody's answering. Lakshmi?
Hello, ma'am.
Yeah, Meera. Now, what is this angle? This angle BOC, how do you explain this angle? It's the angle subtended by
The side CD.
BOC.
BC.
BOC is the angle subtended by the side BC at the center. Then what about angle COD, Hitesh? This angle? Hitesh? Rajeshwari. COD.
Subtended by the side CD.
Okay. So angle COD is the angle subtended by the side CD at the center. We understand that? Okay. Now, so like this, all the four sides subtend the four angles at the center. The four sides of the quadrilateral subtend four angles at the center. Now the opposite angles are supplementary. The opposite sides AD and BC subtend these two angles at the center. Angle 1 and 2 at the center. The opposite sides CD and AB subtend 3 and 4 at the center. The result is angle 1 plus angle 2 is 180. We have proved this in NCRT. I think it's the last one. NCRT second exercise, last proof, I think it is. Angle 1 plus 2 is 180. No, last one, no, that's what, yeah. And 3 plus 4 is equal to 180. There you will be joining, you'll join this and you'll have to join many other things, yeah. But the result is this. NCRT, last exercise, last sum. This is the result you have proved. Angle 1 plus 2 is 180. Angle 3 plus 4 is 180. 1 and 2 are the angles subtended by the opposite sides of the quadrilateral at the center. 3 and 4 are also the angles subtended by the opposite sides AB and CD at the center. They are supplementary. 1 plus 2 is equal to 180. 3 plus 4 is equal to 180. Can we remember this result? Yeah, so I'll change the figure. Now tell me, with respect to this one, what is the value of x? X plus 85 is equal to 180. X plus 85 is equal to 180. Because they're opposite angles, no? They're subtended by the sides AB and CD. So x, how do you work this? X plus 85 is equal to 180. I said I'll change the figure. Okay, x plus 85 is equal to 180. So that's how you work x. I'll change the figure. Need not be straight like this, children. This is the figure. You can see the result there and understand. When a quadrilateral, see that. Where quadrilateral circumscribe a circle, the opposite sides subtend supplementary angles at the center. Understand that? Next one. Now always remember, I've told you, we have done this in the class. Now you have to, in this figure, you'll have to first prove that OQBP is a square. You will have to prove that. You will have to prove that OPBQ, this one is a square. We'll have to prove that this one is a square. Yes, Shreyas, how will you prove that it's a square? As OP is equal to OQ?
And all the angles are 90 degrees.
Very good. How do you say that all the angles are 90 degrees?
And the OQB angle connected or the tangent is radius.
Same thing here.
Then all the angles are 270 degrees and the remaining angles.
Very good. Very good. Yes. All right. So this one, I think in the chapter areas related to circles, this idea has been given to you. We have done this in the class. So how do you prove that this quadrilateral OPBQ is a square? See, these ideas you'll have to remember. Like how you remember the letters from A to Z. You remember different formulae in mathematics like this. Every chapter has some basic ideas. You need to remember these ideas. It's not about revising every sum. It's about recalling all the ideas you use in the chapter. When it is circles, all those first few things which we recall, that one in every sum has a new idea. Now the earlier one, this one was NCRT proof. You must remember this result. You must, like keep a picture of that result in your mind. Words are difficult to remember, but pictures are very easy to remember. So you can imagine a circle and it's circumscribed by, or you can draw. You can, maybe you cannot really imagine it, completely, but you can draw that imagination. So you should draw that. You should draw, like, see, what am I trying to say? You must just draw this, see. To recall this result, you must just draw roughly, okay, a quadrilateral, then with a circle inside it, like this, like you must say that this angle plus this angle is 180. This angle plus this angle is 180. Recalled, finished. In CBSE, they don't test your, English skills. That is, no, you don't. You're not asked to write, state the theorems. Very rarely, if at all, it's asked just one. You're only mathematical. Your number skill is only tested. Proofs, one may be asked. So not much of your, like your language skill is tested here. Only number skills. So you don't have to remember, like a lot of theory here. Just draw this diagram and tell yourself this angle plus this angle is 180, this plus this is 180. Done. That's all. Recalled. Like that. If you can't imagine, see, imagining is one way of recalling things in a very fun way. If that's difficult, just sketch it. Roughly do it. Every sum in the sum patha, you should draw this figure. Understood. Go to the next one. You must recall ideas from every chapter. It's not about working. It's not possible to work each and every sum before the exam. But it is possible to recall the different ideas you've encountered in the chapter before the exam. So recalling of ideas is important. Formulae, ideas, that is important. So your mathematical knowledge is a bunch of ideas. What mathematical knowledge you have is a bunch of formulae, ideas, like tricks, all that to approach the answer to a question. So recall this one. I think I sent the image also. Yeah, next one. Yeah, we were doing this in fact. Yeah, so I'm so happy with Shreyas. So he told it very crisp and correctly that, this is 90 degrees is given. This is 90 because radius perpendicular to tangent, correct? Because BC is the tangent at P. BC is the tangent at P. P is the point of contact. And through the point of contact P, we have the radius PO. So the radius and the tangent at this point are perpendicular to each other, correct? Now, what is AB? AB is a tangent at Q. At Q. And through Q, we have the radius QO. So 90 degrees here. Radius perpendicular to tangent. All right. This is already 90 degrees. Now, in a quadrilateral, the sum of the four angles is 360. We already have 390s here. So the fourth one is 90 degrees. Yes or no? Now, this is a rectangle. If all the four angles are right angles, it's a rectangle. Because only in two figures, we have 90 degrees everywhere. Only in rectangle and square. Only in rectangle and square, all corners are right angles. So this is a rectangle. And how do you prove that the rectangle is a square? When two sides are equal, when two adjacent sides are equal. So as Shreyas rightly said, OP, the adjacent sides OP and OQ are equal because radius of the circle. Or you can also say BP is equal to BQ. Adjacent sides BP is equal to BQ. Why? Tangents from the same external point B to the circle are equal. You can mention anything. You can mention BP is equal to BQ. BP is equal to BQ because they are tangents from the same external point B to the circle. Adjacent sides are equal. Or you can say OP is equal to OQ. So in a rectangle, when one pair of adjacent sides is equal, it is a square. In a rectangle, when one pair of adjacent sides is equal, it's a square. Therefore, OPBQ is a square. So that means what? All the sides are equal to R. All the sides are equal to R. What all the sides are equal to R? Because this is R radius. No, this is radius. So this also, this is not the radius, but the length is equal to the radius. See, definitely BP is not the radius of the circle, but the length of BP is equal to the radius of the circle. The length of BQ is equal to the radius of the circle. Yes or no? So now let's find the radius. We need to find the value of R. Now let's find R. So what is given? AB is 29. AB, this full thing is 29. AD is 23. DS, this one is 5. Okay. Start from that little portion 5. That not the full side. Start with the DS 5. DS is 5, right? So DS is equal to DR, correct?
Yes, ma'am.
Online students, DS is equal to DR. Why?
Tangents.
Tangents from the external point D to the circle are equal. So if DS is 5, how much is DR?
It is
5.
also 5.
That's also 5. Yeah, DR is also 5. Now what is AD? How much is AD? 23. How much is DR? Then how much is AR? 18. 18. AR is 18. Correct, children? AR is 18. Now, if AR is 18, how much is AQ? 18. Because tangents from the
18.
external point A to the circle are equal. AQ is also 18. Correct? Now,
Yes,
AQ is 18. And how much is AB? 29. So, how much is BQ? 11. Then what is the radius?
11.
11. 11. It's 11. So we start from this piece. We start from here. This is 5. DS is 5. So DR is also 5. So AR will be 23 minus 5, 18. If AR is 18, AQ is also 18. So BQ will be 29. The full thing 29 minus 18, 11. So BQ is 11. That means this radius is 11 because it's a square. All the sides are equal. The square, all sides are equal. So R is 11. The value of R is 11. That's what is explained here. Go through. I'll not give you time to write, but you can go through. I'll wait for 3 minutes. Please read carefully. Don't be in a hurry. Yeah, so Nandini, what is step 1 in the order we discussed in the class? Look at the screen and tell me. Look at the figure. Okay, what is the measure of angle OPB? Reason? Tangent 90 degrees. Which is the other angle which is 90 through the same theorem? OQB is 90. Then this one is already given to be 90, right? Okay. So what do you say about the formula?
But when you say that it is a square, and clearly OP is equal to OQ as its radius, and then PE is equal to PQ as the theorem.
Any one will do. You can write any one of the two. That's why I put an or there. You can see this or here. You can mention any one of the two. You can either mention this or this. Very good.
That the quadrature becomes square now. So then it is given that d is equal to 5 centimeter and the theorem that tangents with the external point are equal. It will d is equal to dr and dx is equal to 5 centimeter, and we have given the width of AB now. So 23 minus 5 is 18 now. So through these same theorem, AR is equal to AB, which is 18 now, and so they have given the width of AB. So AB minus AB, which is 11, QB is equal to 11.
So since this is square, all the sides are equal. So R is equal to 11. Very good. Online students, any question? Any questions?
No, ma'am.
No.
All right. Yeah. Find the perimeter. Find the perimeter of quadrilateral ABCD. Yes, Lakshmi, tell us the answer.
1 minute, ma'am.
Yeah.
4 is equal to 3 plus x.
No, we'll do it together. Now tell me, what do you want to find through this? Fast, fast. Tell me the theorem which we'll be using here.
Second theorem, ma'am.
Yes, Priyanka. Which theorem can you do you think can be used here? Bruna? Tangents from the external point to the circle are equal. Okay, so yes, Lakshmi, continue with that. We can use the theorem. Tangents from the same external point to the circle are equal. Use the theorem to find some information.
AP is equal to AS.
AP is equal to AS. One second. AP is equal to AS. So how much is AS?
6 centimeter.
Next.
DR is equal to DS. So DS is equal to 4 centimeter.
DS is equal to 4. So what's the theorem we're using here?
Tangent drawn from an external point.
Tangents drawn from the same external point to the circle are equal in length. Then, yeah, next.
CQ is equal to CR.
CQ is equal to CR. Which is the external point there?
C.
C is the external point. And name the tangents.
CR and CQ.
Name the points of contact.
Points of contact R and Q.
R and Q. Very good. Next.
PB is equal to BQ.
Yeah, correct. So 5. Now what will be the, how much is AB? Answer my questions. How much is AB?
11 centimeter.
How much is BC?
BC 8 centimeter.
How much is CD?
CD 7 centimeter.
And how much is DEA?
10 centimeter.
Now what's the perimeter?
11, 18, 18, 7. $36, ma'am.
36, huh? Oh yeah, 36. 36 centimeter. Very good. That's what I've explained here. Just what you told. Yes, children, go through the answer. All right. Done, online students?
Yes, ma'am.
Yes. All right. Yeah. We need to find angle QSR. QSR. QSR is this one. Okay. So what we have to do is first we'll join. Okay. So join OS OR OQ. All right. Now, what is OR? Radius. R, point of contact. MP, tangent. So is this one 90 degrees? Is this one 90 degrees? It's 90. Sure, all of you? Because it is between the radius and the tangent. It's between the radius and the tangent. You can see this is the point of contact. And this is the radius through the point of contact. This is the tangent. So from the radius to the tangent is 90 degrees. And this portion is 60 degrees. Then how much is this one? All of you understand that? 30 degrees? Okay, so this is 30 degrees. Do the same thing here. See, Q is the point of contact of the tangent and QO is the radius. QO is the radius. So from the radius to the tangent is 90 degrees. The angle from the radius, from between the radius and the tangent, this full thing is 90 degrees. From the radius till the tangent, the angle between the radius and the tangent is 90 degrees. How much is it from here to here? From here to here? 50. So how much is the remaining part? 40 degrees. This is 40. This is 40 degrees. So now so we found this is 40. This is 40 because the full thing is 90, because this full thing is 90. So this is 40. And this full thing is 90. So this is 30. This is 30, correct? Now this one is an isosceles triangle. That's why we recall that. OSR is an isosceles triangle. Why? Because OS is equal to OR, radius. Yes or no? OSR is an isosceles triangle. OS radius, OR radius. So this angle and this angle, they're equal. Isosceles triangle property. See, in a triangle, when these two sides are equal, these two angles are equal. These two angles are equal. So if this is 30 degrees, this is 30 degrees. So this is 30 degrees. This one is 30 degrees. Same thing in the other triangle. Triangle OSQ is isosceles. Triangle OSQ is isosceles. Why? Because OQ is radius, OS radius. So it's isosceles. So by the isosceles triangle property, if this is 40 degrees, this is 40 degrees. Now what's the measure of angle QSR? 40 plus 30, 70 degrees. 40 plus 30, 70 degrees. 40 plus 30, 70 degrees. So now who among the online students wants to explain this? Repeat the explanation. Anybody? Rajeshwari, Meera, Hitesh, Shubha. Yes, volunteer. No volunteers. Okay, here in the class. Come on. Yeah. Okay, let me ask. Deepika. Start. Construction. Join what? Loudly. Join OR. OQ. OS. Join all this. Okay, very good. Then.
Radius the tangents. So then ORM is 90 degrees.
Correct.
XRM. So ORS makes 30 degrees.
ORS. 30 degrees.
Like a radius of a particular tangent. So then, as we have already given, SQ is 50 degrees, and this makes up 40 degrees.
Which angle is 40? Name the angle. SQ? Oh, very good. SQ is 40 degrees. Very good. Next. Name the true isosceles triangles. SOR and SOQ are isosceles triangles. Why is SOR isosceles? SO is equal to OR, radius. So it's isosceles. So what's the isosceles? What is the isosceles triangle property? So this angle is also 30 degrees now. Similarly, here this is 40 degrees. What is that we have to find? QSR. QSR. What will be QSR? 30 plus 40, 70. All right. I've named yeah, I don't like to not like name it SOR, SOQ and all that. So I normally number it, or see I've used X, Y, Y. I've called that little portion X, that little portion Y. I've called this little portion Y. It's very difficult to mark for me, so somehow I've managed to mark. See this little portion, I've called it Y. Can you see? And this little portion, I've called it X. And this one is also X. Why? Because isosceles triangle property. If this is Y, this is also Y. Because isosceles triangle property. Yes or no? Yeah. So 60 plus X is equal to 90. It's easier to present. 60 plus X is 90, correct? Here 50 plus Y is 90. Yeah. So you can see here I've written ORM is 90. ORM. ORM is 90. See, you can see here, ORM is 90. What is ORM? What is ORM? X plus 60. That's why below I've written X plus 60 is 90. ORM is X plus 60 is 90. Similarly, I've written here OQL is 90. What is OQL? What is OQL? OQL is Y plus 50. So below that I've written Y plus 50 is 90. And Y is, so I've used X and Y so that is easy to revise also for you than reading SOR, SRO and all that. Yeah. Okay, so at this point, I would like to discuss another theorem with you, which is called the alternate segment theorem. Have you learned this in school? Alternate segment theorem. All of you have learned circles in school, right? Online students, have you learned circles, this chapter circles at school?
Yes, ma'am.
Lakshmi,
Yes, ma'am.
Rajeshwari,
Yes, ma'am.
Hitesh. So then we'll just discuss this theorem, which is called the alternate segment theorem. We don't have the proof to it. You don't have the proof to this, but you can just use it to find the values of, the unknowns in a figure. So circle, tangent, okay, don't mind that. It's a tangent, all right? It's going into the circle, but please, it's a tangent, all right? Now, chord. Next, I'm going to take up a chord. See the chord I'm taking up through this point. Now, which is this? What is this? This is a point of contact, right? What is AB? Tangent. What is P? The point of contact. Through this point P, I'm taking a chord, not radius. We know the relation between radius and the tangent, 90 degrees. Now we are seeing how the angles with the chord and tangent are related. Chord and tangent. Okay, so through this point P, I'm taking a chord. So see here, anyhow you can draw. Okay, so I'm just doing it like this. What is this? Chord. What is chord? Chord PQ. Chord PQ. All right. Now, what is this angle? It is the angle between the chord and the tangent on one side. What is this? This is the angle between the chord and the tangent on the other side. The angle between the, you can see the chord PQ and you can see the tangent AB. What is PQ? It's a chord through the point of contact P, not any chord. The chord should pass through the point of contact, should have the point of contact as one end. Now, we'll take one angle at a time. Now, let's take this angle, okay, QPB. It's the angle between the chord and the tangent on one side. All right, keep this. Now, for this chord makes two segments of the circle. Because of this chord, the circle is divided into two segments, minor segment, major segment. Now, this is the minor segment, right? This is the minor segment. And a part of the angle lies in the minor segment. A part of the angle lies in the minor segment. So the alternate segment is the major segment. The alternate segment is the major segment. And that's why it's called the alternate segment theorem. That's why it's called the alternate segment theorem. leave the segment in which a part of the angle lies. This angle. I'm not telling you the proof. The proof is different. I'm just telling you how to remember the result. Okay, fine. So what is this angle? This angle, a part of this angle lies in the minor segment because the chord PQ divides the circle into two segments, the minor and major. So a part of this angle lies in the minor segment. So leave that segment. Take the other segment, the alternate segment, which is the major segment. Now, this chord PQ can subtend different angles at any point on the circumference of the alternate segment. You take any point. Now I'm just taking some random point. I'm taking R. What is this point R? It's a random point. It's not that I should take it there only. It's a random point. Anywhere you can take on the circumference of the alternate segment. Mark a point R on the circumference of the alternate segment. Which is the alternate segment here? The major segment. Why? Because a part of the angle lies in the minor segment. So the alternate segment is the major segment. Now what's the next step? Take any point on the circumference of the alternate segment. So I've taken R. Now join the ends of the chord to R. P to R, Q to R. Got it? Now this angle is equal to this angle. This is the result. Angles in the alternate segment of a circle are equal. This is the result. Angles in the alternate segment of a circle are equal. So when you have to recall it in the same way, there's no shortcut. So you should also draw this figure. For that, you should visit this 2-3 times. You should draw a circle. Then you should take a tangent. Then you must mark, look at the screen. No, you can practice it later. Then you must name the tangent. Then you must mark the point of contact. Then through the point of contact, you should take a chord. Then you should mark the angle between the chord and the tangent. And then this is the minor segment. Take the alternate segment. Mark a point R on the circumference of the alternate segment, which is the major segment. Then join the ends of the chord to R, P to R and Q to R. And you can see an angle formed here. This angle is equal to this angle. Angles in the alternate segment of a circle are equal. So you can just write this result. I'll just write angle 1, okay, I'll mark this 2. You must remember what I told you and you should. Angle 1 is equal to angle 2. Alternate segment theorem. Write down alternate segment theorem. Alternate segment theorem. Angle 1 is equal to angle 2. That's all I'm writing. Who has exam or test at school tomorrow? Finished, huh? No exam test. When is the next exam at school? Next Monday. Huh? From Saturday. Alternate segment theorem, which says angles in the alternate segment of a circle are equal. Angles in the alternate segment of a circle are equal. Now, children, in the same figure, okay? Listen, look at the figure, no? Online students, any questions? Hitesh?
No, ma'am.
No, ma'am.
No? Are you there, Hitesh? Hitesh, are you there? Yes, children. Now, in the same figure, tell me another chord through P. In the same figure, tell me PR or RP. PR in the same figure, PR is another chord through the point of contact P. PR is a chord. The same tangent, the same tangent. Now take the other angle. Take the other angle. See this angle? This angle is an angle between the chord PR and the tangent. Yes or no? I'll mark it angle 3. I'll mark it angle 3. What is angle 3? Angle 3 is the angle between the chord PR and the tangent AB on the other side. Now you can make out the segment there. This is the segment. PR is the chord. So this is the minor segment, right? You know, minor and major segment. So this is the minor segment. So leave this one. Take the alternate segment. What is Q? It's a point on the circumference of the alternate segment. Yes or no? And then, then can I mark this angle as 4? So see here, PR is the chord. The Q is the point in the alternate segment. So join R to Q and P to Q. What should you join to Q? The ends of the chord. Which is the chord? PR. Which are the ends of the chord PR? P and R. Join P to Q and R to Q. So now that forms angle 4. So by the theorem, angle 3 is equal to angle 4. By the theorem, angle 3 is equal to angle 4. Reason, angles in the alternate segment of a circle are equal. Understood this? That's all it is. Now for this, now if you see here, A, P, B, okay, we originally took this chord, right? PQ. Now let's talk about this angle. Let's talk about this angle. This angle. So you should take a point here. This is the alternate segment because this is the major segment. The alternate segment is this one. Take a point on the circumference of the alternate segment. Join Q to, what should I call it, R. Correct? This angle. So 5 is equal to this angle 6. This one. This is 6. Angle 5 is equal to angle 6. Same reason. Angles in the alternate segment of a circle are equal. The angle is in this segment, the major segment. This angle 5 is a part of the major segment. So take the other segment, the minor segment. Take a point on the circumference R and join the ends of the chord P to R, Q to R. There an angle is formed. That angle 6 is equal to angle 5. Yeah, make a note, children. I'll just wait for a minute. Fine, children. Made a note? All of you? Oh, let me send a picture of this also, just in case. That is easy, you can understand. I'll just send the picture. It's important, please go through. Simply Pythagoras theorem, children. Simply Pythagoras theorem, nothing else. So when you work out, you please go through this. Just make it fast, okay? Now see here. This is 90, no? Because tangent radius. This is also 90. Because PB is a tangent to the inner circle. PB is a secant to the outer circle, but it's a tangent to the inner circle. Yes or no? This PB is a tangent to the inner circle. It's not a tangent to the outer circle. Don't worry. It's a tangent to the inner circle. And see here, through that point of contact, we have a radius. So 90 degrees here. Similarly, here, tangent. Outer circle is a tangent. This is a PB is a tangent to the inner circle. PA is a tangent to the outer circle. So this is 90 and this also 90. So you have two right triangles, right? Pythagoras theorem. What's given? How much is OA? 5. How much is PA? 12. Can you find OP using Pythagoras theorem? Now you know OP. See, I found OP is 13. OP is 13. Okay. OP is 13 and how much is OB? 3. OB is 3. Now we'll have to find BP. BP using Pythagoras theorem. Which is the hypotenuse in the second triangle? Which is the hypotenuse in the second triangle? OB is the hypotenuse. OP. OP is the hypotenuse. Because it's opposite of the right angle. No, my question is which is the hypotenuse in the second triangle? Because that's opposite of the right angle. That's all it is. Yeah. We'll do this and wind up the session for today. We'll do this one and wind up the session for today. All right. Yeah, children. Now let me just start like this. Yeah. Yeah, children. Now let me start with the calculation of okay, the perimeter of triangle ABC. Can you see the triangle ABC? All right. Triangle ABC. Okay. How do you express perimeter? The sum of the three sides AB plus BC plus AC. Correct? Now, I'm writing AB as it is. I'm writing AC as it is. What you can write BC as BD plus DC. Correct? You can write BC as BD plus DC. Correct? Yes or no? BD plus DC. You're just writing BC as BD plus DC. Now, BD can also be written as BD can be written as BP. Very good. BP. DC can be written as CQ. CD is equal to CQ. DC, CD, whatever, CQ. tangents from the same external point of the circle are equal because BP is equal to BD. These two are equal. Here, external point BP is equal to BD and this one is equal to this one. These two are equal. Okay, so tangents from the same external point of the circle are equal. So we write AB as it is and AC as it is. We first write BC as BD plus DC, and then we write BD as BP and DC as CQ. Tangents from the same external point of the circle are equal. Now, what is AB plus BP? AP. What is CQ plus AC? AQ. Now, is AP equal to AQ? See, AB and AC are not equal. You can't say are equal, AB and AC, because they're not tangents. AB and AC are not tangents. AP and AQ are tangents. AB and AC, they don't touch the circle at all. How can you see the tangents at that point AB? Yes or no? AP and AQ are tangents, correct? AP and AQ are tangents, correct? Yeah, now is AP equal to AQ? Yes, so AP plus I can write AQ also as AP, correct? So that is twice AP. So that means the perimeter of triangle ABC is equal to twice AP. So what is AP? AP is equal to half the perimeter of triangle ABC. Half into perimeter of triangle ABC, correct? This is the relationship between the tangents. See, now AQ is also the same. AQ is also half the perimeter of triangle ABC. AQ is also half the perimeter of triangle ABC because AP is equal to AQ. AP and AQ, they're equal. Tangents from the same external point A. So AP is half perimeter of triangle ABC. AQ is also the same. Now let's do it again. Let's do it again. Perimeter of triangle ABC is equal to AB plus BC plus AC. Now tell me. Next. Online students. Yeah. BD plus plus AC. Next. AB plus plus AC. Next. How AP? What plus what is AP? AB plus BP is AP plus AQ. Now is AP equal to AQ? AQ is equal to AP, right? Because tangent from the same extent point A. So we'll write AP plus AP, correct? So twice AP. What is twice AP? Perimeter of triangle ABC. Perimeter of triangle ABC is twice AP. So what is AP? AP is equal to this 2 will come for division on the other side. So half the perimeter of triangle ABC. Since AP and AQ are equal, AQ is also half the perimeter of triangle ABC. Is also half the perimeter of triangle ABC. Now we need to answer these questions. AB is 5. All that is given. Find AP. What is AP? AP is equal to half the perimeter of the triangle. What's the perimeter of the triangle? See here, how much is AB? How much? AB is 5. AC is 6. And BC is 4. What's the perimeter of the triangle? 15. So what is AP? Half the perimeter of the triangle. So half into 15, correct? Half into 15, so 7.5. 7.5. Now next question is, if AQ is 9, then what's the perimeter of the triangle? Use the same relation. What is the relation? Lakshmi, what's the relation? Lakshmi, what's the relation?
AQ is equal to half of the perimeter of triangle ABC.
AQ is equal to half into perimeter of triangle ABC. Now substitute in the correct place. What is 9?
AQ.
AQ is 9. So 9 is equal to Half the
Half.
perimeter of triangle ABC. Very good. So what is the perimeter of triangle ABC?
15.
Sorry,
15.
how?
Oh, sorry, the second subject.
That's a different. Okay, I understand that. No, this is a different situation.
Yes, ma'am.
Yeah, work this and tell me what is the perimeter of triangle ABC?
18.
Yes,
18.
18. 9 into 2, 18. Correct.
Yes, ma'am.
No, this is I understand your confusion. This is a different situation. I was not asking the first one. This is second
Yes.
subdivision. We have to find the perimeter of triangle ABC. Now that AB is 5, AC is 6, all that is not there. This is a different situation.
Yes, ma'am.
So perimeter of triangle ABC is 18. 9 2s are 18 centimeters. Correct?
Yes, ma'am.
Right. Any questions online, students?
No, ma'am.
Yes, please respond.
No, ma'am.
No.
No? Lakshmi, Meera, Rajeshwari, any questions?
No, ma'am.
No, ma'am.
All right.
No, ma'am.
All right, children. That's it for today's session. Thank you so much. You may leave the call. Good night.
Thank you, ma'am.
All
Thank
the
you,
Thank you, ma'am.
questions discussed today, the pictures have been shared on WhatsApp. So you can start working. You can start completing that in your classwork. All right. I've sent
Yes,
everything.
ma'am.